So that conclusion might look a little bit like this. So this conclusion might look a little bit like, whereas for females there is no change in attractiveness ratings across levels of alcohol consumed. And here I put in my F of 0.05 on 2 and 42 degrees of freedom. Equals, and my F for females was 0.061. 0.61. And my p-value was 0.5456. So whereas for females there is no change in attractiveness ratings across levels of alcohol consumed, for males there was a significant drop-off, or significant decrease in attractiveness ratings from 2 pints to 4 pints. And if I wanted to, I can include the means. So we can go back up to our means table and go, males at 2 pints had 66.88. Mean equals 66.88 to 4 points, where our mean is now 35.63. We can even say from 0 pints or 2 pints, because they're the same, to 4 pints. F of 0.05, 2 and 42, in this case, equals 31.36. And my P is less than 0.0005. Where the comparison of 2 pints to 4 pints, comparison of attractiveness between 2 pints and 4 pints revealed a significant difference. And now, if I come down here, males at 4 and 2, I now have a t-score instead of an f-score. T on 42, so 0.05 and 42. So I only need to say the degrees of freedom for the error term here, because in a t-statistic there's only ever 2 groups. So my degrees of freedom for my IV would always just be 1. So it's redundant. So T of 5 and 0.05 on 42 degrees of freedom is negative 6.86, with a P that is less than 0.0005, following a Tukey's adjustment. If I want to be really technical, I could say between 0 points or 2 points, because we know those statistics are exactly the same. If they weren't, I would write them out one by one. You could even, if you wanted to, if you didn't like that redundancy, you could say for males there was a significant change in attractiveness dependent on alcohol, and get rid of these means and just leave the overall statistics. Let's open this up so you can see the whole thing. Leave the overall statistics where they are, and then say where the comparison of attractiveness between 0 or 2 pints, mean equals 66.88, and 4 pints, mean equals 35.36, I believe, revealed a significant difference. So you can do it like this. This works perfectly fine. Okay, I think that brings us to the end of discussing this particular type of contrast testing, these simple effects in two-way ANOVA. Next week, we're going to look at taking this one step further. And rather than looking at these simple effects where we're looking line by line, we're actually going to be looking at them in terms of a complete picture. So I guess what I'm trying to say here is if we go back to our margins plot, and maybe I need to rerun all of this together. What we've just done today is we've gone, when we were looking at sex by pints, we were asking, are these two means different? And then we asked, are these two means different? And then we asked, are these two means different? Next week, and then after that, we looked at pints by sex the other way. So now we asked, was this different to that, different to this? And then we asked, is this different to this, different to that? So we're looking at each of these lines one by one. Next week, what we will be doing is actually going, well, let's take these two and ask, is this difference here different to that difference there? So what we'll actually be doing is looking at both lines simultaneously, rather than looking at them individually. So it is a little bit more complicated again. All right, thank you all, and hopefully you get something out of this. This is the more pointy end of the course, and things do get a bit more complicated. So if you need to listen to this a couple of times to try and get those ideas together, feel free to do so. And there's plenty of other resources online, including your textbook as well, that can give you some very nice explanations as to what's going on.